Okay, Assalamualaikum and hi. Today our group will present subject control engineering and instrumentation, and our topic is linear encoder. So our group contains 4 people, which is Siwanandan, Zahid Sofia binti Tuah, Siti Sarah binti Hassan, and me, Tuan Nur Nabila binti Tan Muhammad Suzani. Okay, next for the introduction. A linear encoder refers to a sensor, transducer or reading head connected to a scale that encodes position. The sensor examines the scale and converts position into an analog or digital signal. Changes in position over time are used to determine movement. Both optical and magnetic linear encoder like functions using this type of method. So this is the example of the linear encoder system. Okay, a linear encoder is a sensor that records an object's movement along a single axis. Such a sensor is designed with a unique scale and marks on its surface. This passage of marking via the sensor shows a current position charge change. Magnetostrictive sensors are being used to replace linear encoders. Magnetostrictive sensors provide control and feedback without the issue that encoders do. So next slide we will present with my group members. Thank you.
Hey, hi, my name is Sivanandan Alaki Subramaniam and my matrix number is CN2048. So first of all, I would like to thanks to my doctor, Dr. Salihatun, for giving me a wonderful opportunity to present about my case study. So today I'm from group 9 and I would like to present my topic, working principle, about the linear case study which we have done. So okay, so how about the working principle is a linear encoder is a linear position sensor or transducer that monitor the linear movement of an object and provide position response in the form of electrical signal, either in analogy or digital signal. So what is it? It's actually basically the linear encoder consists of signal unit that located on a slider attached to the railway. Okay, now we will look at the diagram. How does it look like? So this is the operating principle of optical linear encoder. Here will be the photo detector where the light can pass through the light source, and this will be the main scale. So how does the principal encoder work? So as we know, first the light source produces a parallel beam of light, and then from there, second, then the signal will pass through 4 windows of scanning. So here will be the 4 windows here. From here, the light will be passing through, and here will be the 4 windows scanning. And then third, the 4 scanning windows on the scanning reticule are shifted 90 degrees apart from each other. Then after that, the measurements with the greatest accuracy and high resolution transparent will be placed on the scale as marking. And lastly, the shifted signals will be combined to create 2 sinusoidal outputs, which is about 90 degrees out of the phase from each other. So this will be the example of wave of output relative to the motion, this one. And second, here we'll see the example wave output with the presence of reference signal for the incremental encoder. So as we can see, this will be the frequency for the first one, relative motion, and this one will be the incremental encoder. So just now we look at how does the principal encoder work. Now we will see operating principle of magnetic linear encoder. So first step, magnetic reader head or rate head and magnetic scale to determine the position of the object by producing transistor logic, which we call TTL. And then it will be analogy output for channel A and B. This will be our A and B. Then second, it uses active or passive scales that can be sensed using Hall effect utilized rate head or magneto-resistive. And then third, there will be a slider passes through each pole on the magnetic scale, and it will produce a transistor. Will compare all the received data with the coded position to obtain the exact position of the object. And then fourth, differ from optical linear encoder of the type of feedback. Then fifth, easy to change color, photos and text, get a modern PowerPoint presentation. So, yeah. And next we will see a simple incremental scale without reference point shown left. Left. An absolute scale right on optical linear encoder. So this how does it look like? It's a schematic diagram for the reference point shown on left, and here will be the right optical linear encoder. So yeah, so this will be the lines which we'll learn through in example of magnetic scale. Each of it consists of a scale. So it is made of conductive for ferromagnetic material which placed periodically along the scale. It receives actually two receiver coil pairs are labeled as VOS and VOC. So when AC current is supplied on the emitter coil, it will be generating an alternating magnetic field, which in turn it will induce eddy current on the scale. So the scale position affects the coupling between the emitter and receiver pairs, which results in amplitude modulated signal in the receiver pair. Okay. Lastly, you will see the eddy currents based magnetic encoder. So I did a comparison of different principal encoder. Encoder type is magnetic sensor, Hall effect sensor, magnetic inductive, and optical. So advantage of using magnetic sensor is better resolution and accuracy, and then better resolution and accuracy also for magnetic inducing, optical high resolution and accuracy. So compared to better, high is much more reliable. So the disadvantage is not suitable under environment with high temperature, can be affected by surrounding magnetic fields. And then for magnetic induced also requires extra demodulation and amplification circuit. And then for optical, it's actually quite expensive and can be affected by mechanical shocks, vibration, dust, water, and alright. So yeah, that's it for my part. Thank you so much.
So for the sensor application in manufacturing industry, the sensor usage in CM. So for the optimizing the sensor usage in optical encoder, the position is determined by using a light source and a detector, but the light is used to detect the sensitivity to dirt and debris, which can distract the signal. So the gap between the scale and the sensor affected by performance of the optical encoder. So as a prevention, scales and sensor needs to be adjusted and maintained so that the signal is not compromised. So for the optimizing the accuracy of the sensor may also be impacted by improper placement. In order to function properly, a sensor must be set correctly, and encoder and incorrect position sensor may cause an output shift or early or sensor failure. The easiest way to prevent a shift carried by improper installation is to program an offset into the sensor controller or change the zero offset using a zero adjustment potentiometer.
As for the future trend, linear encoder has been used in many industries as it is an important component to measure changes in position, speed, count, direction, and linear distance. Encoders transform a motion into electrical feedback signals that may be read by a control device like a programmable logic controller. For example, linear encoder was used in a hydraulic machine or any operation that are using hydraulic system. By utilizing a magnetostriction technology is a linear encoder's max key feature. For the projection timeframe of 2022 and 2028, the market and research.biz has managed a study on the global linear encoders market. In conclusion, linear encoders are like feedback devices as they measure and transmit position and speed across a system. Different linear encoders used in different didactic methods such as a magnetic and optical system and signal readings in either closed or open loop circuits. The accuracy, speed, and format of feedback delivered by different linear encoders technologies will vary, and these technologies can be combined to meet the needs of different applications. Linear encoders have improved positioning across a variety of industries since they are inexpensive and simple to be used, such as the manufacturing and any machining industries. Thank you for listening to our group presentation.